Okay. Welcome everyone to ACDE number 212. Have a bunch of different things on the agenda today, but first thing will be to finalize the list of Fusaka EIPs for DevNet 1. We'll also get some updates on implementation from teams. Then Alan had written a good post about how we should approach testnet deployments after we had these issues with Pectra, so we should discuss this a bit. Then after that, I wanted to discuss a bit how we should approach Glamsterdam scoping under this new process we've been discussing these past couple of weeks. Couple other things related to that around just how we should approach reviewing breakouts, input collection for awkward devs, and then if we have time, there's a couple different proposals I wanted a quick review, but otherwise we can move that async. Before we jump into the Fusaka planning discussion, Perry, do you want to give us an update on the current state of implementations?
Yeah, I can. I'm not Perry, but close enough. So we have PureDAS DevNet 7 currently running. We do not have too much fuzzing going on here. We just basically do a stable spamming of blobs, and different clients are testing whether they are able to sync up and whether they can do backfill. I think as of right now, most of the clients are unable to backfill anything, and we're going to be probably request our clients to have backfill working by like DevNet 1 or DevNet 2. We also do not yet have validator custody implemented by many clients, so we don't really test that because that would just cause unnecessary chaos when we know that it's not supposed to work just yet. But other than that, we have onboarded almost all the different clients. We recently added Bezu as well, and they were also able to sync up to head, and I made some deposits and they have some validators running, and we have 100% participation. So that is regarding DevNet 7, and on Monday we plan to launch Fusaka DevNet 0. And I am actively testing now the different client combos. We have Grandin, Prism, Lodestar, Teku working on the CL side and Geth on the EL side as of now. We're still waiting for Nimbus and Lighthouse to have their branches published for the CL, and pretty much all the other ELs still need to publish working branches.
Yeah,
Amazing.
and to follow up, we have the East tests that were released yesterday, I think, and now there's a Hive instance for it already. We have only one result so far from Geth. So if other ELs give us an image, we're happy to start running them against the East tests. And for PureDAS testing, the security team has a tool that allows us to create network partitions, and I've been playing around a little bit with it. There's a lot more features coming in over the next days, but it seems like the partition test is already failing and might have caught something, so I'll try to dig in a bit more and figure out what's going on there.
Thank you. Yeah, question by Varus in the chat. Have we tried a DevNet without super nodes? Is that something we should test?
Eventually, yes.
So we have not yet, but we will.
We haven't yet. We have a curtosis test for basically creating a perfect PureDAS network where we have 16 nodes, and each node is basically just taking 8 columns for themselves, so no super nodes, and we will have 100% coverage of all 128 columns that way.
Got it.
So technically, we could test this perfect PureDAS and see if it's working fine that way.
Okay. Anything else on the PureDAS DevNets or DevNet 0 that we're about to launch? . Oh, new consensus specs releases. Nice.
So we have reached out to every single client and everyone got back to us. Everyone is still working on implementation. Hopefully by Monday we can have a pretty stable Fusaka DevNet 0. And then we're going to be shutting off DevNet 7.
Sounds good. Does any team think they will not be able to make it on Monday?
Well, we might not be able to make it on Monday because we've implemented like the EL EIPs, but we haven't implemented the PIDS ones, like the engine API changes and the TX pools changes. So maybe like I think some is working on it. So maybe some you can comment on the status.
Sorry, yeah, so, well, I think we might be able to publish a branch. May not be merged into main yet, but we can do that.
Okay. Okay. Anything else on the Fusaka DevNets? If not, then yeah. So last week we discussed finalizing the scope for DevNet 1 on this call and potentially trying to get the full set of EIPs for Fusaka sorted. I think there's value in kind of breaking down which EIPs we want in which DevNet so that we don't have a like set of 6 new EIPs coming in and all the clients working on different ones and making it harder to kind of move forward as a group. So I asked if people could share their preferences for DevNet 1, DevNet 2, and then potentially making DevNet 2 the last DevNet where we accept new EIPs for Fusaka. So this gives us kind of 2 more rounds. And then I guess related to that is whether we should remove some things from the CFI list because at this point we don't think we're going to make them. So 3 teams, I think Nethermind, Aragon, and Besu shared their views before this call. The one thing that seemed like all of them, or sorry, there were 2 EIPs that seemed like both of them agreed should go into the next DevNet. DevNet 1 was EIP 7825, the transaction gas limit cap, and then EIP 7934, the RLP block size limit. Both of these seem like the 3 teams wanted them in DevNet 1. Yeah, I'm curious, Guess, Reth, how do you feel about those?
I'm honestly still trying to understand what the transaction gas cap is trying to target, because I think most of the motivation doesn't really make sense in the EAP.
We're for adding the transaction gas cap. Just to try to answer Matt's point, like it really helps with parallelization and not having to care about this worst case one transaction that you cannot like execute in parallel or rewarm or do anything with it. You just have to do it sequential.
Yeah, but I think that this is kind of missing the point of where we're going, which is large transactions that are batching many user operations together. With 7702, we're almost certainly going to see an increase in the average transaction size over the next 12 months. And it's going to have big implications on things like this.
Andrew, did you want to answer that?
So yeah, we are working on parallel execution and we'd like to avoid massive transactions. Yeah, this This cap will help with the throughput.
Thanks. Roman? Yeah.
Yeah, well, one more follow-up comment is I don't think it is fair to the protocol if the user or like the batcher combines all of the operations into a single transaction and bypasses paying the base transaction cost.
Why is it not fair to the protocol? The protocol's resource pricing is transparent and fair and equal.
So I guess what's the argument for having a no cap? Like if we have a cap now that's effectively close to the block size limit, couldn't we raise it in the future? Is it just that then it becomes bottlenecked on all core devs? And if we have 100 million gas and we don't want to raise the cap to 100 million gas, then people have to pay for 3 transactions instead of 1?
You can only run a transaction that's the size of a block Ethereum, whereas if you've got 4 transactions that are a quarter of the block, you can run them all at once.
Yeah, Julio?
Yeah, I just wanted to say that the limit is kind of at 30 million, and it's basically an entire block. The main the main rationale actually is that if we increase the gas limit, we don't want to have to think about weird worst case transaction cases. So limiting it makes sense for the future. That's the main rationale, just to clarify that. But even in the context of one block transactions, even if you have the overhead of sending 2 transactions per block instead of 1, it's just 21,000 gas. It's not that much really. Yeah.
Yeah, Duncrod?
Yeah, I was wondering, like with the bundles, do we actually have to apply the limit to the bundle, or can't we just apply the limit to the individual transactions in the bundle?
Well, to do that, we would have to have the individual operations in the bundle expose what their limits are. And that's kind of native account abstraction, which we don't have yet.
Right. Oh, so we cannot know what the gas limit for the transactions in the bundle.
Correct.
Right. Okay.
Yeah, I mean, I don't think
Because
this
otherwise,
is...
like the main reason for the whole thing is like a transaction is kind of a nice object with very clear in and outputs, right? But splitting up one transactions can have like very complex state and a big memory and stuff like that. So it feels like for the bundles, that's not actually true. Like you don't actually transfer complex state between the transactions in the bundle. So it feels like you could do something more there if you wanted to.
Yeah. Ansgar?
Yeah, I just wanted to say, I think whether to ship this now in Fusaka or not is not so important, maybe necessarily yet, but I think medium term we will need this anyway. Or there's several reasons. I think also, for example, I mean ZK EVM proving, but then there's also, for example, something that we recently came across, which is that for capping individual types of consumption. So, for example, if you want to like have a maximum amount of S stores that you have in a block or something, that in principle is something very desirable. So we can basically like handle worst cases more easily without making the entire operation more expensive. The problem is that opens you up to this like really bad DOS issues where basically you just don't see in advance how many S stores a transaction will want to consume. So if you basically just have an upper gas limit per transaction, that means, for example, if you have a 10 million gas limit per transaction and you have a 100 million block gas limit, then you just know that you can always set that cap at 10% of what the worst case could be for a block, and you never run into these DOS issues. So basically meaning, I think at the latest in Glamsterdam, we want this anyway. And I think introducing it in Fusaka already with a not so punishing limit, like maybe more 30 million, like it's proposed, I think would be just a very elegant way of doing it now while we have the resources. So I'd be in favor of doing it.
Thanks. Lukasz?
Yeah, so one of the proposed changes for the future are block access lists. And one of the flavor of block access list allows for perfect parallelization. So parallelizing even the transactions that are dependent on each other on the state because of block access list intermediate data, let's say. So here having a cap on the transaction, so basically guaranteeing that there are at least as many transactions in the block would be directly connected to throughput. And in terms of when to introduce this kind of cap, the sooner the better, because this is hard to retroactively change. I think 30 million is, the maximum we should aim for. Even Ben kind of convinced me with his latest stats that we could aim for something lower, like 15.
But the latest stats are not useful because with EIP 7702, it totally changes the structure of how people are submitting transactions onto mainnet. So looking at pre-7702 doesn't give you good data on what could be post.
Yeah, that's a point. So I'm happy to also go with like 30, or if you want 36 million, but whatever. I would like to have something. Then if we go to, for example, in a year to I don't know, 100, 200, 300 million gas, that we will guarantee that there are multiple transactions there.
I mean, okay, even for AA, if the AA bundler sent 2 transactions, they could be run with block access lists, they could be run in parallel and complete in half the time. Whereas if they sent 1 transaction that consumed the block, they would have to run serially and it would take double the time. So, I mean, it's even better that way.
We don't have block access lists, so.
Yeah, but it's proposed for Glamsterdam, potentially.
Isn't this like a security EIP basically? Because we don't necessarily know what such big transactions would do to the network. So like, I think it's better to go the safe way rather than just kind of YOLO it and let whatever size transactions through.
But at the moment, the transaction pool, I think in most clients, limits you to 128 kilobytes. OP Stack can upgrade an entire L2's contracts in under 9 million gas. And of the last 30 days, the only transaction above 5 million gas were scam token sends and Zen contract mining, which can easily be batched in smaller amounts. They're just massive batch transactions, and they could be batched at a smaller level.
Right. So the only argument, I guess, against this limit is that if we move to a future where there's huge AA batches and they're somehow cost prohibitive because they're not amortized, they're amortized across 2 or 3 transactions versus 1. So it seems like, given the potential risks, of not having this and raising the gas limit, we should probably move forward with it. But yeah, any other objections? And yeah, in Glamsterdam, we can always revisit if we want to. Okay, so let's move EIP 7825 to SFI, added to the DevNet 1 spec. The other EIP that base 2 Nethermine Aragon all felt was should be included in DevNet 1 is 7934, which is this RLP execution block size limit. The idea there is to add a cap to the RLP payload to match the CL gossip cap. I don't know if Guest, Breath, two of you had opinions on this.
for it.
I like the idea of capping the size of the block. I've not really looked into the EIP, so I cannot say if I really like the idea of capping the size of the RLP encoded block, because RLP encoding can be quite weird. But yeah, I think in general this idea of limiting the worst size of block that we accept seems good to me.
So if I can add something, I would say the cap is already there. It's just not explicit, and this makes the cap explicit.
Okay. So yeah, and I assume it seems pretty small in terms of change, just like the transaction cap. So any objection to including that one too?
Again, there's a question, do we want to cap it lower, like 7.5 megabytes rather than just the network one? Because it's a direct impact on our recommended bandwidth. Because it's quite large.
Powell, do you have thoughts on this?
No, I just wanted to ask, is this like CL change or EL change? I mean, who will
And
enforce
EL
the
change.
limit?
This is the point. 7934 is adding a cap on the EL block size.
Yeah, that's true, but CL delivers this block to the EL, right? So it knows already that it's too big. So, I mean, who will actually implement this check?
It's the check on block building.
The EL would have to check both. Not build blocks too large and also prevent it. The CL could also do it if they wanted to.
But most of the blocks are coming from the network, right? So you need to check there as well.
So EL will check it on peer-to-peer, like syncing, maybe ERA files importing, for example, if ERA files are not weird in that way. It could also check the blocks that it is building, that they are beneath this value, because if EL doesn't know about this value and builds a too big block, and then the slot will be missed, right? So there are this kind of situations.
Has anyone implemented this check in building and determine like what the impact on building will be? Because if you need to RLP encode the block after every transaction, then that's going to add a lot of extra compute to building.
I mean, it's fairly minimal because you have all the RLP for every transaction already.
But they don't necessarily adapt to the to the results until you actually encode it, right? And we need to predict what the encoding will be on the fly.
It's only the receipts, though. No, only the receipts that, because like if that transaction is RLP encoded already, you can just add that number and then see if there is any receipts also an RLP.
Why are the transactions already RLP encoded if you're building a block? Like the transactions are represented in just your native runtime.
That's how you get them off the network.
And if they don't come from the network, if they come from JSON RPC?
Most likely you use send row transaction.
You probably send the transaction to the network, so you already encoded it, so you can know the length.
Yeah, I just think that we're saying that we can add this check during building, no problem, but no one's implemented it in building, and it seems like it would be useful to actually see what the impact is on people who are building MEV blocks.
Do we even have either that or the blocks fail?
Yeah,
I mean, sure, but if you make it really expensive for them, if you make it expensive for MEV builders to build blocks, like sure, we can impose these protocol constraints, but it's kind of pointless to impose a bunch of compute for them that is not really useful in any way.
Okay, but then they build a block
Sorry.
that cannot be gossiped, so it's essentially an invalid block. So either they check it or they don't, but their blocks can be invalid regardless.
I guess how hard is it to get the numbers around the relative time to encode the block in RLP?
But you don't need to encode it. I think it's kind of easy to predict what it is, by summing just the transaction RLP, which you already have anyway from the CL. And the header is always also fixed size. You know the size of the header too. You don't have receipts, so actually it's just kind of a bunch of additions, which it's not computationally expensive. You don't need to re-encode it all the time while reading the block either if you do it in a smart way, right?
Yeah, it's just the
just a
count.
bunch of additions.
It's just the bytes at the front of the block of the count of transaction.
I mean, you don't need to even re-encode the block. The thing is that you don't even need to encode it. You just need to sum a bunch of numbers.
We have already implemented this in Nethermind, and it's not very hard. So when we're picking transactions, we reject transactions if it will cause the block to become too big, which we had to do for PerfNet and its 5 gigagas limit because we were building blocks that were too big.
Okay. Paolo, is that what you want to comment on?
Yeah, I wanted to ask if we can see a prototype implementation, but Ben already mentioned there is one, but maybe it's time to present it. So because we're kind of discussing if this is easy or not easy, but if you can present a prototype implementation that is simple, I think that's fine. I'm slightly concerned about how we're actually going to test this because I'm sure I want to see 10 plus mega JSON files with the test, but okay, that's maybe the other concern.
The tests are compressed, so if we fill the test with zeros, it's not going to be a big burden, I think.
The check on the CL is on the uncompressed size though, so you're actually going to see the burden even if it's zeros.
I just meant for the JSON files in the tests.
Okay.
Yep.
Okay, so if we have an implementation, the tests seem to work, and it seems relatively easy to calculate this as you're rebuilding the block. Does it make sense to move forward with it and test it on the testnet? Yeah, and Marius has a question about where we actually enforce this in the engine API.
It's part of the static checks on the block. So before you do anything, just check the size of the message.
But the size of the message is JSON encoded, right?
Yeah, but you decode the JSON to get the RLP, which then you decode to get the block.
Under the question around, can we do a cap on the total size of the transactions instead?
Yeah, I think Marius is right. You would have to encode your JSON block to only RLP encode just to check, and then you can proceed. I think this is not ideal.
Julio?
Yeah, that's kind of what I'm sorry.
Yeah.
That's kind of sorry.
Okay,
that's kind of what I'm saying with the I do like this EIP. I just don't know if doing this check on the total, like on the RLP encoded block, is the right way to go, or whether we should do something like Roman said.
Well, I mean, either you can do the check on the message you've got from the CL, or you have to decode it, decode everything, then get the transactions out, and then you can measure it. So it's whether you want to measure it immediately, the CL sent you a block, or you got it from the network. You can just check its size before trying to decode it. Or if you want to do it on transactions, then you have to start decoding the block in order to get to the transactions.
So I guess, yeah, for this EIP, it does feel like we maybe don't have a great understanding of the design space. So should we just take the next 2 weeks to figure this out and try to make a final call about it on the next ACDE? Yeah. Yeah, Julio?
Yeah, I just wanted to say that regarding the alternative design, I kind of already thought about it, but the thing is that it kind of makes no sense to just use like the sum of the transaction RLP and not the rest of the block, because you are actually forwarding the header and like also the header with the block in the CL. So it doesn't make any sense not to include it. And also it's not, it's really not significant difficulty because the header size is capped, like you know it ahead of time. It's not like the only thing you don't know at the time is the state root, but you know that the state root is 32 bytes. So you know the size of the header. So there is no need to keep it out just to have a slightly simpler way, like it's equally simple, essentially. So that's why I didn't really like the design when it was first proposed.
Got it. Yeah, I do think we're a third into the call yet, and there's other things to discuss. So I would hold this one for the next 2 weeks, try to align on a design, and then make a call about it for on the next Alpha Devs. And okay, so of the other EIPs, sorry, let me just look at the list real quick. The other EIPs that people wanted to signal for either DevNet 1 or DevNet 2 were 7907, increasing the code size limit. Besu wanted it in DevNet 2. I think Nethermind was against it, and Aragon also wanted it in DevNet 2. Then EIP 7918, the blob base fee being bounded by the execution cost. It seemed like Besu, Nethermind, Aragon wanted this in DevNet 2. 7212, the R1 curve precompile. There was a mix between DevNet 1 and DevNet 2, and it seemed like people generally wanted this. And then pay opcode was maybe the most contentious, where Aragon just wanted it removed, and then Besu wanted it in the next DevNet, and Nethermind DevNet 2. These are kind of all the other EIPs that are being that were already CFI'd and whatnot. Then we still haven't heard from I guess Reth and Geth on those already. So I don't know if Reth or Geth, you have some thoughts on this list. So 7907, 7918, 7212, and 5920 contract code size, the blob base fee change, R1 precompile, and the pay opcode. Okay, so like client saying he thinks we should have 7212 and 7907. So sorry, Roman, you were just coming off mute.
Yeah. I believe we posted this in the original CFI prioritization list, but basically no strong opinions on 5920 and 7918. And then supportive of 7907. Did I miss something?
The R1 precompile I think Russ
Oh yeah,
supported this.
Yes, this is supportive of it as well. 7212.
Okay, and so for 7907, it seems like everyone supports it except for Nethermind. So I don't know, Nethermind, do you want to maybe share your rationale here?
Sorry, which one's this one?
It's the contract code size.
Yeah, so there's not been a huge in-depth analysis done on it, and if we're increasing the, if our goal for Fusaka, I believe, is performance, and we're increasing the gas limit, and we're potentially increasing the slot times next to it. There's a lot of moving pieces if we then increase the contracts to 256 kilobytes and the init code to half a meg. So
yeah, okay.
It feels like there's too many unknowns with it.
I mean, that's why we meter it though, so you can appropriately charge for loading the code.
Yeah, but I don't feel the analysis on the metering doesn't feel properly looked into at the moment. I agree that it is metered, yeah, but I'd like some more research around it.
Like what kind of research? Like what things would you want to see to be confident that we should do this?
So I mean, we've done a lot of study on the state database, but the code database, I don't think we know much performance characteristics of it. Across clients. I mean, for example, the amount of work that's being put into, can we increase the gas limit to 60 million is quite extreme, whereas the amount of analysis that's done, let's try it on a test net. Let's see what the impact of if we did increase this limit and then we started stuffing loads of contracts with this, what would the performance be? What would the state bloat be? That kind of thing.
Why would state bloat have anything to do with this?
Okay, code bloat. Because you can.
Why does code bloat have anything to do with this? Like the only thing that should matter really is like how long does it take to load the code from the database? And because we can meter based on how long it takes, it's really just a matter of figuring out what the correct cost for that load is.
Yeah, but your code like state is a permanent thing, and you're now saying you can add in a single transaction quarter of a megabyte of permanent storage.
I mean, you can already do that today. You just have to split it across multiple contracts. I think this is one of the most important things that the community has been asking for. And if we're trying to signal that we're listening to them and improving the things about the EVM, then this is one of the best things we can do in Fusaka. I agree, like the exact metering calculations are probably not near as robust as the work that's gone into the gas limit increase, but at some point, like to get the robust numbers, we have to kind of like commit that we want to do this thing. It's hard to get a lot of those numbers when we're doing a lot of other stuff and we haven't really committed to doing the code size increase. And it feels to me that there's only like this one moving variable about exactly how much we need to charge for loading the additional code. And that seems like very like reasonable part of the implementation process of the EIP.
I guess, yeah, so to Ansgar's comment, like, is there actually anything we can figure out in the next 2 weeks, or should we just implement it? But we learn most by actually implementing it in DevNet. Yeah, Powell?
The one of the cost factors is jump analysis, to my understanding of the IP, and I think to my understanding of EVM as well. For that, I plan to do benchmarking anyway in some other contexts, but I think I can commit to prepare some report about this kind of performance and for the next call. In terms of loading from database, I'm probably not the best person to do so.
And so the thing we're concerned about is like if jump analysis is super linear in code size.
Yeah, I mean, I'm not really concerned, but we definitely need to check it. So I will do some, I will propose some benchmarks that, let's say we'll do the same scenario, but with different code size limit, and we can check the current performance with the current limit, the performance of the proposed limit, and this one more limit that comes from the other EIP, which is around 2 megabytes of code. It's the one from that caps the, wow, okay, I'm kind of mixing two dimensions here, but yeah, I can, if you want, I can describe like benchmarking scenarios in the next day, and if that's accepted, I can then work on this to get the numbers. So, or we can prepare the benchmark in some format that anyone can try, right?
Okay, and I guess so for the CIP, all of the teams that had voiced their opinions before kind of supported it for the, or Bayesian Aragon basically supported it for DevNet 2. I think given that there's other stuff for DevNet 1 and we might kind of know more in the next couple of weeks, I would maybe make this call 2 weeks from now, so leave it as CFI'd, and then 2 weeks from now get the final set of EIPs that go into DevNet 2. And yeah, try to at least get DevNet 1 done today, because yeah, there's other EIPs I think people were considering for that. So I guess just like 7934, let's aim to make a final call on this one in the next 2 weeks. And then, okay, so the other one on the list that I think was mentioned by Bayesian, Nethermind, and Aragon, and then I think both Geth and Reth was 7212. There's a bunch of comments in the chat about that EIP having some potential issues and maybe needing a bigger rewrite. I know that when the testing team looked into it, they also said that it had some work, and it was kind of the biggest EIP to test. So yeah, I don't know, Nico, do you want to maybe give some background on 7212?
Yeah, so unlucky us, there is like a slight issue with the existing RIP. It's not a big issue, but with crypto precompiled, you can't really allow any type of uncertainty. So we should just either rewrite the EIP with a small fix and discuss with the rollups that have already implemented it, so they can maybe fork out and go to the new version. Should be doable. Doesn't seem like a huge work, to be honest. Then the question is just always the same, like about like putting the precompile in the clients, and for this I don't really have the answer, but seems like client teams are okay with it. So just rewriting the EIP should be, or I mean, writing a new EIP I think should be the best path forward. And yeah, and working out of the RIP 7 to 12 for existing rollups. I will contact the others to see if they want to champion this, or we can probably do it ourselves if need be.
Yeah, this is a pretty big EIP, so I think, like, yeah, is there anyone
Antonio, I guess, yeah, I guess probably having Antonio from the cryptography team and maybe Renaud from Zkenox, who wrote R1 verifier, would be great. I would, if I could force them to do it, I would.
Is there anyone else on this call who can like spend the next 2 weeks looking into this? Because I agree, like, I think a lot of people keep saying that this is really important, but if we,
yeah, I can take the burden, but not like I can champion the thing, but on the math side, I would defer to Antonio or cryptographers with a lot of experience. Yeah.
Andrew?
So I'd like to suggest, because we're going to make a change, then this RIP is already deployed on Polygon. So probably the safest route is to deploy it on Ethereum in the standard precompile range of Ethereum and keep the original contract at the RIP address unchanged, and then say smart contracts on Polygon, if they want to use the newer version, they just use the Ethereum address.
This is the difficult part. I'm not sure you want to be in a situation where like one signature can produce two different outcomes.
Right. So different code should be at different addresses.
Yeah.
Yeah.
Yeah, that's what I'm saying.
Yeah.
Oh,
yeah,
okay.
that
Sorry,
feels like
yeah.
That feels like a no-brainer. Hadrian?
Yeah, I just wanted to say that I don't think it's just about RIP 7212.
Adrian, your mic is cutting.
We don't to not know where the precompile is and have to guess. Like if OpenZeppelin or Solidity or any other library wants to make something that is SCP 256 R1 compliant, we don't want to have to check the chain ID and then go to which precompile it is that we want to use. And I don't think Solidity wants that either. Like nobody wants that.
I mean, Solidity is going to have to do this though, because we're not going to end up in a world where everything on mainnet is going to perfectly match the L2s or vice versa. Like we have to have compile targets.
And also like there's an issue. It's like if there's a bug with it, it seems impossible to avoid.
Well, I think in this case, it's not a big problem because for Polygon, it's deployed on a different address, starting with hex 100 or something. So if we deploy it for Ethereum on the standard range of addresses, then it can be ported to Aragon, and it will be like all the L2s can simply enable Ethereum's version at Ethereum's address, and it will be the same.
That would be great, yes.
Yeah, they can obviously redeploy it. Yeah. Okay, so it seems like Nico and Stokes can look into this over the next 2 weeks, but there's broad support, so should obviously leave it CFI'd and then have it as a candidate for DevNet 2. Does it make sense to people?
Yeah, let's do it.
Yeah, and so to recap, so right now we already had the mod XP EIPs that are going into DevNet 0, along with obviously PeerDAS and the BPO forks. We said we wanted to include the transaction gets limit cap in DevNet 1 as well. We're looking at metering the code size limit and increasing that for DevNet 2 potentially. looking at 7212 for DevNet 2 potentially. So the other EIP that, the other one, we're looking for DevNet 2 is this RLP increase. So we already kind of have 3 in flight that we need to figure out for DevNet 2. The other EIP that seemed to have broad support is 7918, which is the blob-based fee one. And I think, let me check real quick. So Besu, Nethermind, Aragon all wanted it in DevNet 2. I don't know, Geth and Reth, how you feel about it, but if we like it, I would maybe push to have it in DevNet 1 rather than DevNet 2, given it's simple and we already have a bunch of stuff pending for DevNet 2.
Sorry, which one?
S7918, the blob base fee change.
Right. Yeah. I mean, I think it's simple to implement, but like strategically, it's very complicated, and I honestly don't know if we've really had the time to make sure that this is the type of thing that we want to do, increase the cost of blobs to L2s. That seems like a major decision, and it shouldn't just be sort of wrapped up into the DevNet.
Okay. Ansgar?
Yeah, just to briefly report from that side. So Anders has been kind of continuing to work on this quite a bit. I think Anders might also be on the call and can give an update there. But basically, high level summary is just that, like, while looking at this, there was some people noticed that even today, basically, blob transactions are to some extent underpriced because they have this compute overhead of the proof verification that's not accurately priced in the normal gas right now. The leading proposal right now is to just basically use that as a baseline for the minimum price for blobs. But the nice thing is, basically, in terms of like DevNets here, as long as we are certain that we want to ship this at all, we can just go ahead with implementing this, because the only potential change like that is contentious here, or where we might still want to change our mind over the next few weeks, would be the exact level of this minimum price, and that's literally just a constant in that EIP. So that is a constant value that is just used once in an if clause. So basically, like that's just at the very top of the EIP, and if in 2 weeks or so we say, hey, actually that's a bit too high for L2s, we don't like that, we reduce it by half or something. If that's already implemented in the DevNet by then, that's one constant change. So I think it would be safe to go ahead with implementing this now already. But when mentioned on that, I think my understanding is that there would be one more update to the EIP that I think Anders would have ready, like by whenever it has to be ready, like by Monday by default, but also like by the end of today or tomorrow if necessary, with some small spec clarifications until then.
Yeah, do you hear me? Yeah. Yeah. So I can just mention that. Yeah, I can just mention that. So there was this recent analysis I posted in the chat, and if we expand the rationale a bit by accounting for the compute cost that blobs actually impose on our nodes, and we can use this to consider different constants. And anyway, I will just update the EIP with these reflections during the weekend, so we could then have some exact specification on Monday for the testing code, for example. But it's essentially that we would go with the if clause that looks more like the one in that text that I posted, but it's just a change of constant actually. Yeah, so the implementation is very simple, as Ansgar says.
Okay, so and then there's some comments about maybe moving it to Glamsterdam. So I guess, yeah. Does anyone feel strongly we should include it in DevNet 1? Otherwise, we can discuss this in the next 2 weeks and then see if we want to include it in DevNet 2. But I will flag that we're starting to have a bunch of stuff that's like TBD for DevNet 2. Yeah. Yeah. Okay, so no strong support for DevNet 1. Then, okay, the last one we haven't discussed yet. Well, I guess why not DevNet 1? I don't think any team has signaled towards that. And then some of the teams think we should move it to another fork. So
Happy for DevNet 1. It's much simpler than the base fee. We already have a PR for it.
okay, so never mind. I mean, okay, so Andre in the chat saying why move it to a different fork? Like, I think Roman and Likekind were both saying we could push it to a different fork. It's not a priority, so.
I mean, one of the issues is we're massively altering the blobs, and then we're having BPOs, so we're messing in the blob market massively in terms of supply. So it's better to have it in before that.
Yeah, there's a question on this. Do you know what do we expect the change on fees to be? And I know there's many different moving parts here, but yeah.
Maybe I can, yeah. So, I mean, this is the conversation we can have when we tune that constant, essentially, depending on how we want to sort of balance between, on one side, we might want to actually charge blobs for the compute that they impose on nodes, or we would like to ensure that the fee market functions, and on the other side, we want to keep blobs very cheap. And we can just, the point is that we can just set this constant rather low, and by doing so, we ensure that we are not imposing like a race to the fee that is substantial when we compare it with the cost of the blob kind transaction itself.
And maybe just to reiterate, how exactly then does it improve the functioning of the fee market? Like, that sounds interesting to me. We have this EIP, and there's a parameter we can tune so that the fees end up in like a nice place. But then it sounds like we also get this other benefit of better functioning fee market. Does this,
Yeah,
this touches on like
well,
the
so
issue?
essentially, blob consumers are affected by the execution base fee, because they have to pay for the blob kind transaction anyway. So if you want to set some low limit to the blob base fee, then if we have that limit reflect the execution base fee, then we can sort of assign a limit that will adjust correctly dynamically with how the demand for blob consumers shifts, essentially.
In the chat, Terrence said that the L2s actually want this. So Terrence, do you want to give some context on this?
Yeah, so I can speak on behalf of Option Labs. We've done like a bunch of research over blob feed market over the past few years, right? And one deficiency that we have seen before is just that when the blob-based fee is very, very low, it essentially becomes a parity gas auction. So people start bidding heavily on tip. And that's not very nice because that's not something that's predictable. So we want something that's more predictable in a way that like, and then it also varies a lot because of like blob mempools have different rule set versus transactions. So basically, in a way, it's more strict. In a way that you have one blob that has a higher tip, then you kind of crowd out the like six, like for example, like 6 blobs. So there's no like a small like mix and match. It becomes like a PA. It becomes a very hard problem to solve, and that's why builders started opening up their custom, like basically their custom endpoint, and people start using that because this allows more flexibility, and that's not very nice. And one way to solve this is just have a basically like a very predictable like base fee in a way that like when it essentially rises up so much, it's like basically the curve is more smooth. So in a way this actually helps layer 2, like basically because of the base fee wouldn't suddenly just spike.
Okay, thanks. Ansgar?
Yeah, I mean, I just want to say, because if there's still uncertainty whether we want to ship this in Fusaka at all, I think we just need to have the discussion today, because we won't have any new information in 2 weeks. And so like the more we push these, like the more we end up having to make the discussion rushed. So yeah, I would just argue for that we should today decide to include this. That doesn't mean we can still wait for DevNet 2 to actually like have it in the DevNets if that's preferable. I think there's no reason to not do it in DevNet 1. But yeah, and then we can still, for example, like I do think the one concern that is reasonable is this question of whether that basically that constant parameter should be so high that it at least like somewhat meaningfully now is a portion of the overall cost of a blob transaction, even if it's at the floor level. But that we can decide in 2 weeks. In 2 weeks we can have like a proposal comparing, like, say, two different values for this parameter, one very conservatively low, one a bit like this higher proposal. See just concrete numbers of, like, in terms of dollar terms, like what would the percentage change be for sending a blob transaction in either of these scenarios, and then just choose one of the two. And so if that means that we would want to like wait until DevNet 2 to even just include it in the DevNets, that's fine. I think it could already be implemented as of today.
Yeah, I would lean towards, if we think we want to do this and it's a question of what the fee is, then I would move it to DevNet 1, because we have less stuff for DevNet 1 right now, and this is a fairly simple addition. Yeah, so I guess
I would be very for it being in Fusaka. DevNet 1's fine. It's an easy implementation. And since in Fusaka we're including BPO forks, and we're constantly changing, we're messing with the blob supply continuously after Fusaka. I think it's quite important to stabilize the market.
Okay, so any objections to moving it into DevNet 1? And we can obviously tweak the constant as we learn more about the impact, but at least we'll have this implemented in clients and tested. Okay, so let's do that. Let's move this one to DevNet 1. And then the last EIP on our list was the pay opcode. This one was the one that had the most, I guess, uncertainty around. So Aragon was against it. Besu and Medamind maybe disagreed on when we should do it. So I don't know. Yeah, Geth and Rhett, do the two of you have opinions about it?
Sorry, which one again?
Pay opcode 5920.
Yeah, Emily, I'll have just some comments on the ETH Magicians thread, but I understand that a lot of people really think pay is important. I'm a bit worried about the implications on our compute model, because sending ETH without execution makes it difficult to do accounting nicely. But obviously we can already do this today with self-destruct, so it's not really like it's adding new functionality. I'm kind of indifferent, but we have a lot of EIPs that we are considering to include, so maybe it doesn't make as much sense.
Any thoughts from Russ? I would break the current MEV boost flow.
Yeah, in a way that currently relays validations that the sender is the I guess maybe you cannot trigger the pay opcode in the payout transaction. It just proposers, they often set the recipient to like a contract address, and they do different kind of stuff with the ETH that they receive.
Okay, so just because we're also kind of getting low on time, and this one was kind of contentious, I would maybe not remove it now, but I think in the next 2 weeks, like, yeah, if client teams want to review that one alongside the 3 other ones we're considering for DevNet 2, which is 7212, 7907, and 7934, and we can make a call about which ones we include. Does that make sense? Yeah, so and I'll update my message here that I had in the chat, but so in practice, it means that for today, we would have 7825 and 7918 in DevNet 1. We review 7212, 7907, 7934, 5920 over the next 2 weeks. We've removed 7762, and then on the CL call next week, we should review the proposer look ahead EIP 7917. Yeah. Okay. Anything else on Fusaka scope? Yeah, so only 2 new EIPs for DevNet 1. Yeah, and the goal is we launch DevNet 1 before on June 9th at the latest. Okay. Testnet deployments. Alan wrote this post on Ethereum Magicians a couple months ago. Alan, are you on the call? I'm not sure. Oh, I don't think he's on the call. So basically, okay, the idea was that we should really avoid breaking testnets for application developers, and basically try to get a commitment that Hudi should be the kind of long-term application testnet, meaning that at the very least we should fork it only like when as the last testnet when we're sure. Yeah, so I guess the people feel strongly about like trying to keep Hudi the last testnet that we fork. One concern is that we'll never have. So Sepolia for devs. Yeah. So one concern is that we'll never have like a perfect staging environment unless we effectively fork it after mainnet, because there's always a risk of bugs. But then Sepolia is not sufficient to deploy complex LST protocols. So they kind of need Hudi for that, and therefore, like, yeah, we would want to make Hudi more of a app like stage environment. Oh, and I think Alan just joined.
Hi, everyone. Thank you for having me.
Yeah, do you want to give a quick context on your proposal? I was just trying to summarize it, but doing a poor job of it.
Yeah, I would love to. So my name is Alan. I'm from the SSB network. We are running a DDT network. We've kind of went through the entire kind of crisis, quote unquote, with the last fork. And it became obvious that stability in testnets is something that has a lot of value for developers, both in terms of not needing to wait for testnets, integration testing, and also in general, stability gives a lot of value to just developing and kind of predictability in development. And so after the latest forks for came up with the idea of maybe proposing at least one testnet that will be stable long term and also as close to mainnet as possible in terms of its in terms of our risk appetite, meaning that we fork it last and we don't quote unquote experiment with it, but rather it's quite literally a minute from going to be forked a minute before mainnet. And so I wrote about it in Ethereum Magicians, and then Tim and others suggested I open it up to this conversation where the proposal is really to take Hudi and try to make it app-developer testnet long-term, encourage a lot of developers to treat it as their stage environment, meaning for them to deploy their contracts. That's really important for integration testing and so on. And maybe more importantly is to try to fork Hudi with mainnet or as close as possible to mainnet, and not as a testing fork, but rather just a fork that needs to happen both on mainnet and Hudi. The result of that will be signaling to the developers and in general signaling to everyone that Hudi is really here as a really, really stable testnet for everyone to deploy their contracts and make sure that we don't have those issues like we had before, where either the testnets forked out not in a good way, and then we kind of got stuck without testnets, or every 6 months, maybe 12 months, changing testnets, which in of itself is quite difficult for developers to do. So that's kind of my summary of everything.
Okay, thanks for sharing. So there's a couple comments in the chat around, yeah, like that it's kind of hard to have forever running testnets, but I don't know, like, yeah, Barnabas, yeah, like clients. You want to add more?
I know that I spoke with a bunch of people from the EF. I think there is a kind of a people don't really want a forever going testnet. I would actually maybe challenge that, and I'm not entirely sure why it's a bad thing. We have a forever going mainnet, so why not have like a forever going stage environment? But even a very, very long term testnet, which is carries as minimal risk as possible in terms of forks, and also actively encouraging developers to treat it as their stage environments, so we can have a lot of different projects having their contracts there in a stable manner will really help with a lot of the integration testing and in general just the stability and predictability of development.
Right, and I think, okay, so the challenge with these long-term testnets is always just the state. Like they become harder and harder to maintain, and there's kind of no incentive for anyone to run nodes there. So historically, you know, most of the nodes on these testnets are run by client teams and the EF DevOps teams. So you could imagine, so I guess what Barnabas is suggesting now in the chat is we could also imagine just having a community run testnet that's long running, that even forks after mainnet. The challenge is actually finding people to run those nodes and do so over the long term. Yeah,
maybe I have a suggestion there. So most of the staking infra and applications already have a substantial amount of nodes running just because of the nature of what they're building. And so potentially we can harness them for that aim, basically them taking the bulk of the work of running those testnets. It's going to be favorable for them as well. I know projects like Lido and us and others really want that stability, and we also obviously run testnet nodes because we're doing a lot of testing around staking and the infrastructure we're building. And so potentially there is a way for guaranteeing a kind of a community driven, where the base of it is those types of projects which anyhow need to run a lot of infrastructure for testing because of the nature of their product. And also we can harness others. Maybe, I don't know, from the top of my head, maybe a project like Gnosis really needs nodes as well, because that's something that they constantly need to make sure their development is going correctly, and also their users have a lot of integrations to Gnosis, so maybe that's beneficial for them as well. So maybe we can find a set of community projects of community members that are willing to run it long term. 6 years is amazing, but realistically, if I look at different networks for different things, realistically, we are finding ourselves jumping from testnet to testnet quite more frequently than I would love to.
I feel like you're conflating testnets and devnets here, though. Like, you've listed these YOLO devnets, and they're not really intended to be used by developers. Since the launch of Sepolia, we've kind of had this plan of having minimum 5 years per testnet for like many of the reasons that you're describing. So I think it's important to disambiguate the fact that there are pretty long running testnets. The main issue that we've run into is that there was a hard forking bug recently on Husky.
It's not only that. Sorry, go ahead.
I'm just saying, had we not had that, I don't think that we'd be having this conversation.
We definitely felt testnets. We're jumping from testnet to testnet more rapidly, more frequently than we would have wanted. Maybe Sepolia, for example, is long running, but not everyone is on Sepolia. And we did, like, going back to Prater and others, we did find ourselves much more frequently than 6 years changing testnets for various reasons. So it's not always the intent, but that's realistically.
I mean, sure, but
at least our experience.
Sure. I mean, I totally get it, especially when the merge was sort of happening and the testing was happening, then it totally makes sense. The timelines were far shorter, but I think now we are in a much more solid position and we have made a pretty strong commitment to having testnets 5 to 6 years. And so, like, you can definitely expect that. There is an issue with Husky that we have to fix, and we should have a higher standard for what we put onto testnets. At the end of the day, we have a good track record for forking testnets, and we've only had one hard forking bug in like the last 5 or 6 years. We should continue to minimize that, but sometimes it happens, and it's devastating for the whole testing ecosystem. I just don't really know if there's a way around that.
I think it may be a matter of just defining, in a way that is much more communicated much better to developers, and also kind of enforcing those. So if we do say, okay, this particular test is for 6 years, maybe a decision to minimize the risk in terms of the forks it goes by. Again, very close to mainnet, or even after mainnet, or with mainnet. Even those small decisions will greatly affect the stability of it. So it's less about having a designated testnet, more about like setting a few. I don't know. I don't want to say rule, but like put a few conditions of how we treat those testnets. It can really go a long way in stability.
So I think one thing we can do is commit to forking Sepolia first, and that. Historically, we kind of didn't want to do this. We thought Hudi would be kind of the more chaotic testnet, but then we kind of realized that because of the open validator set, there's a bunch of stuff that can only be tested on Hudi. I think generally forking Sepolia first is a good approach there. In terms of forking after mainnet or at the same time as mainnet, then that feels like a whole new testnet we'd have to stand up, because realistically, we generally only have 2, and there's value in getting 2 kind of dry runs before mainnet. But then, that's maybe something that the community could stand up, which is like effectively a mainnet staging environment that only forks after.
After it may be too aggressive, but very shortly before or right with the mainnet will be great. And again, I think it's about risk, right? So if we're forking in order to test something, then we're carrying more risk on that testnet, and that's fine. It's a staging environment, that's fine. But I think that kind of there's a trade-off between that, right? So maybe
there is. And realistically, like the thing like we do try to minimize that risk as much as we can through DevNets, but there are some things that end up only being possible to test in like semi-production environments like testnets. So like we'll never get the risk to zero. I think we can more clearly communicate that like, okay, we'll fork Haleshki first and then Hudi, or sorry, we'll fork Sepolia first and then Hudi, meaning that like Hudi should be least risky to be forked. But yeah, realistically, that risk is not zero. And we, you know, barring having another testnet that only forks after mainnet, I don't think that there's a solution that brings your risk to like equal or less than mainnet. And yeah, potentially like, yeah, we could have just done this slower for Pectra. Yeah. And I guess on the comms too, like I think we can definitely make that clearer, like as we're working on the fork, like, okay, which testnets are forking and when and why. Yeah.
What about encouraging or gently pushing more developers to really have a stable instance of their contracts on whatever testnet it's going to be, to really improve integration testing and in general the kind of interoperability between.
Yes, we do this, but they don't listen to us.
Yeah, so can I raise a point here? So I really wish everyone would deploy everything as soon as possible on DevNet. And it's just not realistic because DevNets will break a lot. So this is why we have testnets, and this is why we have the longer a testnet runs, basically, the less it's going to be deployed on the future DevNets, because everyone that deployed on Girdley, for example, might have left the company, and whoever they hired have no idea how to deploy on a new testnet. So this is why I think it would be actually better to have more testnets, not less testnets. We want everyone to deploy everything on the testnet and make deployment basically as easy as possible and as automated as possible. So if anything, we should probably aim for less testnets, not more testnets, not less.
I can only kind of speak from our experience. I can only speak from our experience, but there's definitely more than one testnet people are referring. We, for example, find ourselves both on Sepolia and Hudi for some reason, for the same set of contracts. And so I can only kind of reflect what we've experienced. So every much less than 6 years trying to kind of change testnets, definitely using more than one for the same set of contracts. And I think that kind of if I need to put like a goal in mind of how an amazing testnet should look like, it's something along the lines of, I don't know if anyone ever interacted with a Stripe stage environment. It's amazing. The developer experience there is amazing. That's kind of my beacon of hope where testnet can be and should be. And I think we're quite a long way from there. Yeah, that's kind of from my experience and what we've been through the past couple of years, maybe 3 years.
And I think, like, yes, this is kind of a qualitatively different thing almost, which is like we having a staging environment that forks after mainnet might look different than having a testnet that we test upgrades on. And in practice, like, if you're like a company like or a project like SSV or Obol or like any other liquid staking provider, you're gonna kind of have to be on all of them because you're not just like writing contracts, you're working on like core staking infrastructure. But then if you're just say like a Uniswap or like a any kind of DeFi or NFT contract that doesn't actually interact with the validator set in like a complex way, you can imagine having like a pretty good stage environment that's just based on that just forks after mainnet and that brings the risks to basically zero. But it'll be harder to do for something like staking pools.
I don't want to name names, but it's from from our experience, it's not just the types of apps which are going for the staking infra and the user facing sides. A lot of kind of core, not core, but like very, very common types of applications. It's a lot of work to get them to work on stage environments, and I think a lot of that is because of that ambiguity. Where should I deploy? How stable it is, and so on. And again, it goes back to the developer experience and how easy it is to build something. Most applications are not standalone. Most application interaction with other types of contracts. I think from ENS to Gnosis to Oracles to anything other than that.
Okay, I just want to be mindful of time here. Like, I think, I think we should table this for now. But I agree that there's probably something around application development that we can build that's better. But the current like core dev testnets, beyond just moving to Hoodie being the last one and reducing risk, I don't think we can significantly change. Light Client, you want to discuss the RPC proposals?
I think I saw Zane on the call.
Yeah.
Zane, did you want to mention?
Hey, yeah, thanks. Hey, Zane here from OpenRPC. We actually do a lot of the documentation work for the APIs and things like that. And so recently what we've done is we've overhauled OpenRPC, the ecosystem. So they're kind of new major version bumps. So like for 2x, I did see a change coming in for like Docusaurus because people were having a hard time running locally. But actually, the newer version, which is like on 2x for the generator, generates things like sort of locally. It allows you to run everything with the modern Node.js ecosystem and things like that. There's other things like spec extensions, which we just added. So there's now a roadmap to add new items into the spec and to support things like error groups, which I'm going to pass this over to Raj very shortly to talk about the error groups proposal. I'm going to link drop real quick. Basically, there's a lot of cool things that we can do in the spec now that we weren't able to do before. And we've been working with Chainlink to like allow clients to be able to specify error codes in a more sustainable way. Because currently within the spec, there's only like one error code, but there's a lot more error codes that are out there. And it's a question of like, how do we organize things and get that going? So I'm just gonna pass this over to Raj because he's done a lot of the implementation work. And from the OpenRPC side, we've just been updating the ecosystem to do more awesome things. And I recommend you check out the tools repo because, like, again, we've started overhauling things. So use Node.js 20 whatever, and you'll be good to go. Okay. Raj, you want to take it?
Thanks. Sorry, actually, so we are kind of at time. Yes, sorry about that, but I asked in the chat, like, where can people kind of discuss this? And I think there's a channel on the Discord, but is there also like a RPC standardization call next week? Is that right? That might be like a better place.
That's right. That'll be 8 o'clock on Monday.
Yeah, so I think that might be a better place to have like a longer deep dive discussion because we're already at time and there's a couple other things that we need to draw people's attention to. Sorry about that.
Okay.
Yeah. Do you have access to the Discord and all of that?
Yeah, I can drop this in the RPC channel in Discord. Which Discord? ETH R&D?
Yes, correct.
Okay.
Okay, thanks.
Thanks.
Okay, and so we didn't have time to get to the Glamsterdam stuff today. I think it's just fine. We can discuss it in 2 weeks. Obviously, we should basically figure out Fusaka before we do that. And then in addition to this RPC proposal, there were 2 other proposals that people wanted to get feedback on. So I'll just post these in the chat. And yeah, people can review those async. And then in terms of next steps, so next week, let's make a decision about the proposer look ahead EIP on the CL call. And in the next 2 weeks, finalize the decisions for DevNet 2. And by definition, what kind of exclude everything else from Fusaka, so we have at least a full scope. Anything else before we wrap up? Okay, well, yeah, thanks everyone, and talk to you all soon.
Thank you.